Okay, everyone, we're moving on to Chapter 8 here. We're going to start Chapter 8, which is all about similarity with a section on dilations. Dilations is something that was from way back in the beginning of the book when we were talking about transformations. We did mention dilations. And so what the first section is about is basically just kind of reviewing that and then trying to tie it into similarity, which is what Chapter 8 is all about. Okay, let's take a look at this first problem here. And in this first problem here, we are looking at a couple of points here, A and B, and we're looking at the center of dilation being the origin. So here's the center of dilation, here's a point A, here's a point B. And it says draw the dilation of a segment by a scale factor of 2. When we talk about a scale factor, it's K equaling 2. Keep in mind that when the scale factor is bigger than 1, it's gonna get bigger, and if the scale factor is less than 1, it's going to get smaller. So the image points A and B can be found by simply doing this, kind of figuring out how far it is to get from here to here. And what we're going to do is we're going to use some vector notation, some notation that indicates that it's going 3 in the x direction and 6 in the y direction away from the origin. Now if I apply a scale factor of 2 to this, all I'm going to do is multiply both those numbers by 2. So now it's going to be 6, 12. So from here I'm going to go 6 in the x direction, and I'm going to go 12 in the y direction, and I'm going to end up all the way over here. So my new point is going to be 6, 12. Or that'll be my A prime. Likewise, I can do the same thing with B prime, and what you're going to end up with is it's going to be at 10, 2 for my B prime, doing the exact same thing. So 10, 2. And then if I draw a line connecting A prime, B prime, hopefully you can see that that line segment is going to be twice the length, okay, or double the length of the original. And if you want, you can go ahead and calculate it using the distance formula. But for now, I'm just going to go ahead and tell you that that is double. And if I go ahead and draw in all these little segments from here to here and from here to here, what you're going to find is that if I measure this distance from O to A, and that's going to be, if I calculate it using distance formula 3 root 5, the distance from the origin to A prime is just going to be double that, or it's going to be 6 root 5. 6 root 5, and I can do that again using the distance formula. I can find that. And you're going to find the same thing is true with O to B, which is just going to be square root of 26. And O to B prime is going to be 2 times the square root of 26. So these lengths are just going to double. So when you're dilating by a scale factor of 2, you're basically blowing everything up by a factor of 2. And if the scale factor were half, everything would be shrunk by a factor of a half. Okay, let's move on to a problem on the next page. Okay, the problem I want to talk about is problem 4 here. And so if I want to take P as my center of dilation, and I want to take this triangle, ABC, and dilate it by a factor of 3, what I'm going to do is take this distance from here to here let's call this x, and then I'm going to blow it up. I'm kind of eyeballing it here. I don't have a good measurement tool, but this is going to be 3 times the length away from the center of dilation. So that'll be C prime. Likewise, I'm going to do the same thing for x. Or for A, and I'm going to kind of double it, and there's going to be my A prime, and then my B prime will be somewhere like this. My B prime will be down here. Connect the dots, and there's my new triangle. And hopefully you can see that I just basically blew up that triangle by a factor of 3. So this is the new triangle here. This length, the perimeter, is going to end up being 3 times the perimeter of this thing. And what we're going to find out later on is that these two triangles are what's called similar. They're similar to each other. Now, I do want to bring up one thing here. If I said that the scale factor was -3, what that would mean is if in the original part, when we were finding the C prime, so this is x, that would mean that instead of going 3 times x in that direction, it would just go in the opposite direction. So it would go 3 times x, but it would go in the opposite direction over here. So this would be where C prime would be. And then likewise, you can do that with all the other points, A prime and B prime there. Just wanted to point that out when you have a negative scale factor. It basically is talking about taking a segment with endpoints -5, 2, -2. So right here, and B is 6, -4, which is right here. So this is the segment we're talking about, and what we're going to do is we're going to dilate that segment. And the center of dilation is going to be at 3, 1. So there's the center of dilation. Now, and what we're going to do is we're going to dilate this by a scale factor, or a scale factor of k, equaling 1.5. Now, if you remember, looking way back at the beginning of the school year, when the k factor is bigger than 1, the resulting transformation is going to be that the figure is going to get bigger. When it's less than 1, it's going to get smaller. And when it's negative, it's going to go in the other direction. So we'll talk about that a little bit as we approach this problem. There's 2 ways to approach this problem. The first one is, what I could do is I could take P and I can move this to the left 3 and down 1, so that the center of dilation actually ends up being at the origin. And basically I'm going to take all these and move it to the left 3 and down 1, left 3 and down 1, like this. Okay, and then from there I'm just going to go ahead and multiply everything by the scale factor 1.5. And then don't forget that when you get to the end, you have to move everything back up 1 and to the right 3. I'm going to go ahead and try this problem without doing that, though. I'm just going to move it using the scale factor that's given there. And basically, what I have to know here is that, okay, from P to A, what is my difference here? It's going to be from P going to A, it's going to be -8 in the x direction and -3 in the y direction. Okay, so we're sort of putting that in using vector notation there. And so if I multiply this, both of these, by 1.5, I'm going to end up with moving this -12 and -4.5. So I multiplied negative 8 by 1.5 and negative 3 by 1.5 and got this. So from the center of dilation, I'm just going to go negative 12 in the x direction, and then I'm going to go negative 4.5 in the 4.5 in the y direction. So then I end up right there. And so the result is going to be, I'm going to end up at a prime equaling negative 9 comma negative 3.5. Okay, so that's this point right there. And I can do the exact same thing for my b coordinate. And when I do that exact same thing, well, let's go ahead and do this quickly. P to b is going to be negative 3 in the x direction, negative 5 in the y direction. Multiply that by 1.5. So p to b prime is going to be 4.5 in the x direction and negative 7.5 in the y direction. Again, I'm just multiplying the original x and y values by 1.5. So b prime is going to end up being, if I go 4.5 in the x direction, negative 7.5 in the y direction, it's going to be 7.5 comma negative 6.5. And those will be my new coordinates for a prime and b prime. Okay, we're on the back side here. We're talking about this triangle right here being a dilation of the original triangle, which is the orange one right here. Okay, and we have some values here. This is 7, AB is 14, CE is 3, and BD as an entire length is 18. Okay, we're supposed to find the scale factor that's used to map this smaller one to the bigger triangle there. And so let's just take a look at an individual point. And if you look at this, here's the center of dilation, and the original amount was going in this direction, 3. Now, we didn't really talk about it on the front side, but basically when it goes in the negative direction, when your scale factor is negative, the resulting point will actually be in the opposite direction. So this is going to end up giving you a negative scale factor. And you can see that this scale factor here is going to be bigger than 1 because this amount 7 here, is bigger than the original amount, which is 3. And so keeping in mind that what we usually do is we take the 3, which is the original amount, multiply that by the scale factor, and you will get the new amount, which is 7. So your scale factor in this case would just be, solving for k, 7/3. And we know, because it's in the opposite direction, that this is going to be a negative. That means that the point went in the opposite direction. So we have a negative scale factor. Now we're supposed to find, on the next part here, we're supposed to find the length of DE, which is this one right here. Let's call it y. And so using the same thing we just did, it's going to be whatever the value of y is, which we're looking for, times our scale factor, which is negative, well, let's just use positive 7/3, because we know it's going to be in the opposite direction already. We don't need to use the negative. So negative 7/3 is going to give you, over here, 14. And so if I solve for y here, multiply both sides by 3/7, y is going to be equal to 14 times 3/7, or it's going to be equal to 6. So y is going to be equal to 6. So that would be the way to do this using scale factor. So this is, let's call this method 1. The second method is really what where we're headed with this. So I'm going to kind of split the screen here, or split this problem here, and call this method 2. And this basically hints at the similarity type of problems that we're going to be doing and using proportions. So just to kind of give you a little foreshadowing here, what I can do is I can use this. So 3 is to 7. So 3 from the smaller triangle is to 7 of the bigger triangle, as y from the smaller triangle is to 14 from the bigger triangle, which is the corresponding side over there. And again, if I solve for y here, I'm going to get y equals, and I solve this thing, I get y equals 6, which is what we were looking for. Okay, so let's try that method for this next problem here for finding the length of DC. So DC, let's call this x, and we know that the entire length is 18, so that means that this portion here is going to be 18 minus x. That's what this portion right here is going to be. So if this is x, and the entire thing is 18, if I subtract x, I'm going to get that portion right there for BC. So I'm going to set up the same proportion. So it's going to be 3 from the smaller triangle is to 7 from the bigger triangle, as x is from the smaller triangle is to 18 minus x is from the bigger triangle. Then I'm going to cross multiply, okay, which we'll talk about quite a bit in the next section here. And so 7x is going to be equal to 54 minus 3x, or x, 10x is going to be equal to 54, or x is going to be equal to 5.4. Okay, I think that's it for this problem here. I'm going to let you go ahead and I know that this was kind of crazy in that I introduced some new methods here and here, but I'm going to go ahead and let you try some problems on your own. All right, good luck.